Let us summarize. An equation involving derivatives of the dependent variable with respect to independent variable is known as differential equation. Now let me tell you one thing. If any equation is having dy by dx or dx by dy form, dp by dt form, any of this d by d form, you can say it as a differential equation. What is the order of the differential equation? This is the order of the highest order derivative, which you can find in that differential equation. Degree of differential equation is what? It is defined if it is polynomial equation in its derivative. Degree, when it is defined, because we have to see whether it is defined or not. So degree, when it is defined, of any differential equation is the highest power, only positive integers, of the highest order derivative. So highest power of highest order derivative is the degree. A function which satisfies the given differential equation is called its solution. So the solution which contain as many arbitrary constant as the order of the differential equation is called the general solution, and the solution which is free from any arbitrary constant is called as a particular solution. So to form a differential equation from a given function, we just differentiate the function successively, and how many times we do it? The number of times we have arbitrary constants in this given function, and then we eliminate the arbitrary constants. We have also a variable separable method. This variable separable method is used to solve an equation in which the variables can be separated completely. Terms containing y should remain with dy, with x should remain with dy. A differential equation which can be expressed in this form, dy by dx equal to fx by y, or dx by dy is equal to gxy. In these two are homogeneous equation of degree 0. These are called homogeneous differential equations. So a differential equation of this form, dy by dx plus py equal to q, where p and q can be constants or function, this is known as, or this is called as first order linear differential equation.